Hello, Ben. How's it going?
Django, very good. How are
Hey,
you?
thanks for joining me. I'm good. The year's progressing. We have, or the second trade show that we normally visit in person is now being executed as a digital event. So Photonics West 2021 has just been completed. And I wanted to take again the chance to do a review with you of what we have seen, where we see the trends are heading towards, and what does it mean to Sunex products.
Sounds good. It's a nice picture of San Francisco. I miss it. Missed it this
Yeah,
year.
same here. In general, what I've seen when I went to the online content and the digital content, again, as always, Photonics West is the show to show the new technologies, right? Things in healthcare, advances in security and transportation, manufacturing, and obviously a lot of like fundamental science and discovery. So that hasn't changed. Um, us as Sunex, when we exhibited at the Photonics West in San Francisco, right? For us, it was always bringing our technologies to our customers and discussing those things in particular with them. What was for you a typical reason why we went to Photonics West in person as well?
I think the nice thing about Photonics West is that it's so broad, and they have everything from filters to glass to lasers. I mean, it's applications, it's fundamental science, it's test equipment. It's a chance to reconnect with the industry, but also to see what's new out there. What are the trends that are emerging? And one of the trends that we're here to talk about, I know that we've seen not just at Photonics, but other places, is this SWIR topic.
Yeah, absolutely. So, right, we have a very broad range of core technologies, and we discuss all of those. But again, this year really, I noticed also there when I looked at it, I think there were well over 20 presentations focusing on SWIR and why that is so interesting. We have always been very much involved in hyperspectral or day-night application, for instance, with our security customers. And in most of those cases, right, we had to one side the visible spectrum, and then people wanted to kind of break into the near infrared spectrum, whether that's maybe at 850 nanometer or 940. But really this year, and not only at the Photonics West, but also if I see my newsfeed, my inbound in my inbox, I see a lot of talks about SWIR and what those technologies can be used for. And I think it's just appropriate to use our review of Photonics West and maybe put it under the context of SWIR and see where we're heading with that.
Yeah.
So in general, right, it's the spectrum gets pretty wide there, the infrared spectrum, and it breaks down mainly in two big areas. One is the reflected infrared spectrum, which is represented by the near IR range, which we are utilizing. And now, again, the new hot topic, shortwave infrared, the SWIR band. Mainly in this area is sensors that are trying to detect signals here. They are picking up on photons that are reflected off an object. Whereas if you keep going up in the wavelength spectrum further, in the infrared spectrum, the thermal infrared is represented by mid-wave and long-wave infrared spectrum. And this is where actually the objects in themselves start emitting light and radiation. So that's roughly the breakdown. And SWIR in particular is of interest for various applications, and customers utilize it to different needs. But in general, when you look for like high contrast imaging, especially during the night, ambient and background radiance from, for instance, stars from the night sky is already a natural SWIR source. So it lends itself again for good day-night applications. But also in some areas, it's a very important feature that we have here in this range is where water particles pretty much become transparent. And so one of the shortcomings of visible systems, right, if you think about a foggy night in San Francisco, there's not much that a camera on a car would see. But here, SWIR can actually help overcome some of those shortcomings. So with that, the application space is very broad, right? SWIR is not a technology that has been just in its advent. It has been around for quite a while. Military aerospace quite often pick up those new technologies first, and then we see communication and satellite technologies and the surveillance and security space, medical application, agriculture, all the way down to food processing, sorting, automotive, even art and archaeology. They use those type of technologies to do what they actually want to do. What we noticed is there's a trend where in the past, quite often, especially also, again, if we bring it back to Sunex, optics have been very expensive and very specialized. So you had more these applications where you had a very few of something very specific. And now again, you and I, we see that in our news feeds. The trend is really going to a broader market. You have a variety of applications in higher volumes as well. So we're really going from this very specialized application to something that is addressing more the broader market, and typically board mount cameras, right? So we're basically back to building normal cameras. People just want to expand the wavelength spectrum. So with that, if we're looking at standard cameras, maybe you and with your experience, if you could address a little bit, what is Sunex now taking into considerations when designing a lens purposefully for SWIR imaging?
Yeah. Well, first, it's important to recognize that, like you said, this isn't a new technology. You know, what has changed, you know, that makes this suddenly viewed with a lot of interest from all these different applications. And I think there's been a recent advent of high temperature or ambient temperature and lower cost SWIR sensors, and it's driving sort of a revolution or a rediscovery of applications, whereas before it might have been prohibitive in terms of size or cost. And this is a good segue into, you know, why Sunex is interested in this and what we can potentially do for a customer, is because we have for many years done high value add and high volume camera and lens module assemblies for the visible and near infrared market. And now, as you said, customers want to expand the usable spectrum further into the SWIR. And this is definitely still the realm of, you know, some traditional optical materials and designs. And so what we're able to do is make small compact versions of these SWIR cameras utilizing this new sensor technology. And when you look at SWIR lens design, there's some things that are unique to SWIR. There's some things that are in the realm of traditional optics, we might say, but certainly there's some considerations for the SWIR. And what we see in a lot of these applications, first off, is the material choices for the lens designs themselves. It's like what we've done in the past with hyperspectral, but extended even further. So things like anti-reflective coatings and filters, choosing the right spectral weightings all become important in the design. And when you look at the actual coatings and optomech, there's some material science here, right? Things that are opaque might be transmissive. Things that are matte black might look reflective when you go into the SWIR. So it's not just the optical design, it's also the optomech, it's the surface treatment. And then we have to look at the first order parameters too. So what does high MTF mean? Is high MTF in SWIR the same thing as high MTF at 12 megapixels in the visible? No, it's different. And so we have to look at the application, the use case, how these things change when you look at SWIR. And so low F number, yes, still a thing. People want more light, whether it's visible or SWIR for these kind of low light applications. But stray light also becomes a challenge. You have a much bigger range of stuff to account for one, unless you're filtering out specific wavelengths. Different materials and coatings, as we talked about, behave differently at SWIR. So a lot of the same, but also a lot of different and unique considerations that are specific to SWIR.
This sounds pretty much, again, we're not going to have a single SWIR product, right? It's again, we're trying to seek the dialogue here with the customer and the client to really figure out what the application is. From what I have seen as well, if I compare SWIR sensors, for instance, which now the ones that has been recently released also go really from the visible all the way into SWIR application, right? So they really allow for a very broad spectrum, or maybe cut out the band niches that you're interested in. But the resolutions are a little bit smaller at the moment, right? So we're not talking yet about 4K and higher. But I think having the competencies and technologies in-house from our current experience and current market segments is key to help this SWR market also grow into a mass market into the future, right? Things like thermalizing a design just becomes more and more important. So I think, again, having the optical design, the optomech design, and manufacturing all in-house, and already having this whole suite of technologies and a vast experience already in visible and near IR range, and having already designs ready for SWR, I think is just putting us in a very good space to service those markets who will take on SWR moving forward.
Like we said, of course, there's some unique considerations to SWIR, but the basic science it translates, right? It's still applicable. The techniques for athermalization, the techniques for bore site stabilization, the techniques for making low distortion lenses, it's all applicable. It needs to be adjusted for SWIR, of course, but as you said just now, exactly right. All of these technologies that we've done in the past can be brought to bear on this. And there's no reason to think that this is not analogous to what we've seen in every other market with every other sensor, starting out at lower resolution, bigger pixels, gradually going to more resolution, smaller pixels, which is going to require more of this kind of precision tolerancing, athermalization, and things like that.
Okay. So with that, we're also bringing our short review of the Photonics West 2021 to an end. We don't have to repeat all that content that is online. I really just found it interesting that SWR just gets kind of more and more into the news. So for us, I think it's probably one of the important product and new technologies and competencies moving forward. So Ben, thanks for your time and for your input.
Yeah, and thank you, Ingo. And of course, to the people listening, if you do have an SWIR requirement, please feel free to reach out to us and let's discuss it and see how we can help you.
Thank you.